Hello everyone, welcome back to the channel. I hope you are getting the concept clearly. If you have any doubt, then let me know in the comment section below. Okay. Today we are going to discuss star to delta conversion technique. In the previous lectures we have discussed how to convert delta to its equivalent star. Now in this video we are going to discuss how to convert the given star network into its equivalent delta network. So let's get started here. We have already discussed what is star and delta network. Okay, the figure shows this is the star network. This is star network which is given to us. This is the given network. Okay, and this is the network we want. Okay, and we have to convert from this star to its equivalent delta. Okay, we have already know these values R1, R2 and R3 as the circuit is given, and we want to calculate this R12, R23 and R31 values when this given star is converted to its equivalent delta network. Okay, and we are going to do that with these expressions. Here R12 is calculated with the help of this expression, R1 into R2 plus R2 into R3 plus R1 into R3 divided by R3. Similarly R2, R23 and R31 also can be calculated. Here observe here the denominator for all the resistances which are connected in delta are same, and let it will be delta R. This is delta R, and this is also delta R. And what is this delta R? It is nothing but sum of products of two resistances each time. Okay, it is the sum of product of two resistances each time. At a time two resistances are taken. Suppose this R1 and R2 are taken, R2 and R3 taken, R3 and R1 taken. Okay, these are the three possible combinations, and product of these three is taken. And now the sum of these three is nothing but delta R. Okay, the sum of these three products is nothing but delta R. Here numerator for all the expressions are same, and in the denominator observe here when we want to calculate this R12, denominator is R3. That means in this R12, 1 and 2 suffix are there, 3 is missing, so divided by 3. Here R23, 1 is missing, so divided by 1 R1. Here R31, 2 is missing, so divide it by R2. Okay, in this way we can remember these expressions. Okay, now let's see with the help of diagram you can how to remember this with the help of this picture. Okay, here the star is given network. This is the outer delta which is drawn with dotted line. We want delta. Okay, here we know the values of R1, R2 and R3. We want what is the value of R12, this R23 and R31. So when we are converting the given star to a delta, draw this delta, required delta, with dotted lines in the same diagram. It will be easy to remember also and easy to calculate also. Here we want R12. Okay, where is R12? Here R12 is there, which is connected to this 1 point and 2 point. Okay, this point is left unconnected to this R12, so this will be its denominator R3. Okay, see in case of R23, the numerator for all same, delta R, and this is also delta R. When R2 3 is connected to 2 and 3, so its denominator will be what? Its opposite, R1. R1 will be its denominator. In case of R3 1, which is connected to this 3 point and 1 point, its opposite is what? R2. So right here R2. And we have already discussed that delta R will be the sum of product of two resistances at each time. Okay. So this will be the delta R. In this way, we can convert the given star to its equivalent delta. Okay. Remember this, when we are converting star to delta, numerator is same. When we are converting given delta to star, denominator is same. We have already discussed this conversion from delta to star, where denominator in the expressions are same. So remember these 2 points. Okay. Now let's solve some numerical based on this technique. Here question is, convert the given network into its equivalent delta network. Here 1, 2, 3 are these 3 points. Here is a common point, and 12, 12 and 12 ohm are connected in star. Okay, we want its equivalent delta network in this formation. Okay, this will be 1, 2 and 3. So draw the required delta with dotted lines. This will be the required delta. This will be the R12 as it is connected to 1 and 2 points. This will be R23 and this will be R31. Okay. So we have to calculate here these 3 values. So let's calculate R12 as the 3 resistances are same. Okay, the values of resistances connected in the star network is same. So its delta equivalent resistances also same. So R23 equals to R31 will be delta R divided by any one resistor, suppose R1, or it may be delta R divided by R2 or delta R divided by R3. Okay. So first we will calculate delta R. What is delta R? It is the sum of product of two resistances each time. So 12 into 12 here, again this 12 into 12, again this 12 into 12. This will be 432 ohm. So putting values here, 432 divided by resistor value is what? 12 ohm. So it will be 36 ohm, and this is the required answer. So all the values which are connected in its equivalent delta will be R12, R23, R31 are 36 ohm. Observe here, all the values are connected in star is 12 ohm. When they are connected in star, they are 12 ohm each value, and when they are converted, to delta, the value are 36 ohm, and this delta is equivalent delta of star. Okay, remember this equivalent delta. So that means R delta is equal to 3 times of R star. R delta is equal to 3 times of R star, and this is applicable where all the resistances are same. And in the previous lecture we have already discussed that when we are converting from delta to star, what will be the resistor value? 1 upon 3 upon R delta. Okay. So these two expressions are important. These two expressions are same when we are converting from R delta to Ry, 3 times Ry, when we are converting from delta to Ry, 3 times Ry. Okay. And this is 1/3 of the R delta, that is resistor connected in delta. In this way, we can easily find out the equivalent resistance values when they are connected in delta. Okay. Let's do one more example. Here, let's change the color first. Calculate equivalent resistance RAB using delta star transformation. Okay, this is the given circuit. Suppose these are the A and B points, so this will be the C point. Here, we want to calculate this RAB. Okay, the resistance RAB, equivalent resistance RAB using delta star transformation. Okay, this is the star network inside this delta. Okay, so delta is also there, star is also there. So we have to use here 3 reduction techniques. One is when the resistances are connected in series, when the resistances are connected in parallel, and third one is star delta transformation. Okay, where we are using all these 3 in this problem. Here, inner star has to be converted in delta for reduction, so draw its equivalent delta with dotted lines. Okay. This 10, 10, 10 all are same, so this will be, suppose this is R1, this is R2 and this is R3, also are same. R1 equals to R2 equals to R3, and we are converting from star to delta. Star to delta. So its numerator will be same divided by 1 resistor. Okay, because the values are same. So delta R, first calculate delta R. Delta R will be sum of product of 2 resistances each time. So 10 into 10 plus 10 into 10 plus 10 into 10. This will be 300 ohm. So delta 300 divided by 10 will be 30 ohm. So R1 value, R2 value and R3 will be 30 ohm. Let's redraw the circuit. These are A and B points. This is outer 10 ohm. This is also 10 ohm. This is 10 ohm. Okay. So inner delta will be this will be the inner delta having values each 30 ohm. 30 ohm, and this is C point. Now observe here, this 10 ohm and 30 ohm are connected in parallel. This also connected in parallel. This also connected in parallel. So this 30 ohm and 10 ohm are connected in parallel. So what will be its equivalent? Equivalent will be 30 into 10 divided by 30 plus 10. This is 300 divided by 40 is nothing but 7.5 ohm. So each parallel combination is now 7.5 ohm. This also 7.5 ohm. This is also 7.5 ohm. Now let's redraw the circuit again. Here we have C point, and these are point A and point B. This is the A point, this is the B point, and this is C point. Now these are 7.5 ohm, this is 7.5 ohm, again this is 7.5 ohm. Here we want the equivalent resistance RAB, that means the resistance between this A and B. When we measure the resistance between this point A and B, what will be the equivalent resistance of whole circuit? Okay, so we have to again reduce the circuit. Here, observe here, we want this A and B, the resistance RAB, okay, between these 2 points. So this cannot be changed. So this 7 point and 7.5 ohm. Observe, by standing here, we want the resistance between these 2 points RAB. So these points cannot be changed. Okay. So this 7.5 ohm will be remain as it is, and this 7.5 and 7.5, the combination of these two, this 7.5 and this 7.5 are connected in what? Series. Are connected in series. So for series, there will be summation 7.5 plus 7.5 will be 15 ohm. So now the circuit will be what? This same 7.5 ohm. Okay, these are the A and B points. And now between these A and B points, we have another resistor having this 15 ohm. This 15 ohm connected here. This is the resultant of these two connected in series. Now here also observe here, this 15 ohm and 7.5 ohm are connected in parallel. Okay, so RAB will be parallel combination of 15 ohm and 7.5 ohm. So it will be 15 into 7.5 divided by 15 plus 7.5, and we will get the value of 5 ohm. Okay, so required equivalent resistance of the circuit shown is nothing but 5 ohm. Okay, this is the required resistance value. With the help of this series, the resistance is connected in series, resistance is connected in parallel, and star delta transformation technique, we can reduce the circuit to a single resistor. Okay, now this is again a similar circuit that we have solved. This is the outer delta, this is inner star. Okay, the procedure is same, as we have to convert this against this inner star to its delta. Then this delta will be in parallel with each other. So again reduce in that manner only, and try this question and let me know the answer in the comment section below. We will appreciate those who are commenting correct answer in the next session. Okay, and we will also solve this problem in the beginning of next session. So till then, stay tuned and keep learning. Thank you.